Hello my dear friends, how are you all? I hope you all are fine. So my dear friends, you are very welcome in our lecture number 5 of triangles. Okay, so this lecture is going to be very amazing, so you have to be listen very carefully. Okay, so now let's start without wasting the time. Okay, so today my dear friends, here is we are going to discuss some more criteria for congruence of triangles. Okay, so in previous lectures we already learnt about the side angle side rule, angle side angle rule, and angle angle side rule. Okay, so here today we are going to discuss side congruence rule, means triple S congruence rule. Okay, and this is the theorem 7.4, and it states that if three sides of one triangle are equal, if three sides of one triangle are equal to the three sides of another triangle, okay, then the two triangles are congruent, okay. Now let's suppose we have two triangles PQR and XYZ. Okay, and if all the corresponding sides are equal, then we can say that triangle PQR is congruent to triangle XYZ. Okay, so now here we have to prove the congruency part. Okay, so here is, now let's prove. So now first of all we have to write the given part. Okay, we have to write. So now what is the given part? We have triangle PQR and triangle XYZ such that all the corresponding sides are equal, means PQ is equals to XY. Okay, QR is equals to YZ, and PR is equals to XZ. PR is equals to XZ, means this side is equals to this side, and QR is equals to YZ, and PR is equals to XZ. Okay my dear friends, so now we have to prove triangle PQR is congruent to triangle XYZ. Okay, so for proving this condition we have to do a construction. What is, we have to draw a construction, we have to draw some lines. Okay, so now here is in the construction, we are drawing a line XW. Okay, we are drawing a line XW from point X which intersecting YZ, such that it is intersecting YZ such that angle WYZ means this angle is equals to angle PQR, means angle PQR. Okay, and WY is equals to PQ and WY is equals to PQ. Okay, and now join WZ and join WZ. Okay, so now my dear friends, here is we can write as by construction angle WYZ is equals to angle PQR and WY is equals to PQ. Okay, I hope you get this point. So now let's start to prove this theorem. Now in triangle, here is PQR and triangle WYZ, means PQR and WYZ in these triangles. Okay, here is, we know that PQ is equals to WI by the construction. PQ is equals to WI. We can write it as by construction. By what? By construction. And angle PQR. Angle PQR means this angle is equals to this angle, again by construction. So angle PQR is equals to angle WIZ. This is by construction. This is by construction. So I hope you understand these things. So and here is QR is equals to YZ. This is, we know that this is the given part. So QR is equals to YZ. This is given. So we can say that triangle PQR is congruent to triangle WYZ. Congruent to triangle WYZ. Okay. And this is by what? This is by, you can see that side angle side. Side angle side. Side angle side rule. Okay. So this is side angle side rule. So I hope you understand these things. So we have two triangles PQR WYZ. Here is WYZ. So they are what? They are congruent to each other. Okay. Okay. So from this we can write as, we can write, here is angle W, means this complete angle is equals to angle P by CPCT. So angle W is equals to angle P. Got it? So this is by CPCT. This is by what? CPCT. So this is equation number 1. Okay. Now let's suppose this is what? This is equation number 1. So I hope you understand these things. So now in this case, now here is, now in triangle X, Y, W, means this triangle X, Y and W. We can see that, we know that PQ is equals to Y at WY. PQ is equals to Y WY. Okay, PQ is equals to WY by construction. By construction. And PQ is equals to XY. This is given. This is given. So we can say that PQ is equals to WY and PQ is equals to XY. So we can write, here is WY is equals to XY. Okay, WY means this is equals to this. So we can say WY is equals to XY also, means this line is equals to this line. Okay, and here is, we can say angle 1 is equals to angle 2, because by what? By the theorem, angles opposite to equal sides are equal. Okay, so we can write here as angle 1 is equals to angle 2. Angle 1 is equals to angle 2 by angles opposite to equal sides are equal. Equal sides are equal. So this is, we are giving, this is a second equation. This is second equation. Okay, I hope you get this point. So now similarly we can prove that, we can prove angle 3 is equals to angle 4. Similarly we can prove angle 3 is equals to angle 4, means this angle 3 is equals to angle 4. Got it? And this is the third equation. This is the third equation. Now, so now we are going to add, equation second and third. So we get what? We get, here is this equation. Second and third, we get angle 1 plus angle 3 is equals to angle 2 plus angle 4. Angle 1 plus angle 3 is equals to angle 2 plus angle 4. Okay, and here is, we can see that angle 1 plus angle 3 is what? Angle X. Angle 2 plus angle 4 is what? Angle W. Angle W. So we can write as angle X is equals to angle W. Angle X is equals to angle W. I hope you get this point. And we know that also, here is, yes, angle W is also angle P. Angle W is also angle P. from 1. We have also angle W is equals to angle P. So we can see that angle W is equals to angle P and angle X is equals to angle W. So we can write here as, here is, you can see that angle X is equals to angle W and angle W is equals to angle P. So we can write from these two equation, angle X is equals to angle P. Angle X is equals to angle P. So this is our fourth equation. This is our what? This is our fourth equation. Okay. So here is now in triangle. Now in triangle PQR means PQR and triangle XYZ. Here is, this is X, Y and Z. Okay. So now my dear friends, here is PQ is equals to XY. This is given. We know that very well. Angle P is equals to angle X. This is from equation 4. This equation, from this equation. Okay. And here is PR is equals to XZ. This is also given. Okay. Means here is side angle side. Okay. Here is also side angle side. Okay. So we can say that here is triangle PQR is congruent to triangle XYZ. Congruent to triangle XYZ. Got it? So this is congruence by what? By side angle side criteria. Side angle side rule. So we can say that, my dear friends, if all the corresponding sides are equal to the other triangle, okay, then we can say that these two triangles are congruent, okay, by triple S rule. So I hope you understand these things, my dear friends. So we can write hence prove. Okay. Yeah. So now let's move on. So here is, we are going to discuss theorem 7.5. We are going to discuss theorem 7.5. Okay. So this theorem is RHS congruence rule. RHS congruence rule. So now here is RHS full form. We know that right angle, hypotenuse and side. Okay. So RHS is what? Right angle, hypotenuse, side. Congruence rule. Okay. So now this theorem states that if in two right triangle, we have two right triangle ABC and DEF. If in two right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. Okay. So now in this, angle B and angle E are what? They are 90 degree. Okay. And AC and DF, so they are what? Hypotenuse, which are equal, and BC and EF, one side which is equal. Okay. So now we can say that these two triangles are congruent to each other. Okay. So we have to prove this congruency part. So now first of all, we have to write the given part. So what is the given part? Yes, we have two right triangles. Two right triangles. Triangle ABC and triangle DEF. Okay. Here is angle B is equals to 90 degree and angle E is equals to 90 degree. Okay. And the hypotenuse is equal, that is AC is equals to DF. They are what? They are hypotenuse. Okay. And one side is also equal, which is BC is equals to EF. BC is equals to EF. Okay. And we have to prove triangle ABC is congruent to triangle DEF. Is congruent to triangle DEF. Now let's start the proof. Okay. So in right triangle ABC, okay, by Pythagoras theorem we can write as AC square is equals to AB square plus BC square. Here is AC square is equals to AB square plus BC square. So this is what this is by Pythagoras theorem. Pythagoras theorem. Okay. So from this we can find AB square is equals to AC square minus BC square. So this is equation number 1. This is equation number 1. Now in right triangle DEF, again by the Pythagoras theorem we can write DF square is equals to DE square plus EF square. In this DF square is equals to DE square plus EF square. Okay, so from this we can find DE square is equals to DF square minus EF square. DF square minus EF square. Got it? So this is equation number 2. This is equation number 2. Okay. So we know that here is in equation number 1 we can write here is AC is equals to DF. So we can write DF in place of AC, and here is BC is equals to EF. So we can write EF in place of BC. In place of BC. So here is in equation 1 we have the equation what we have AB square is equals to AC square minus BC square. Okay, so from this we can write, we know that here is AC is equals to DF and BC is equals to EF. This is the given. Okay, so this will become AB square is equals to DF square minus EF square. Okay, so from equation number 2 here is DF square minus EF square is DE square. What is DE square? So this will become AB square is equals to DE square. AB square is equals to DE square. So we can write here as AB is equals to DE. So this is equation number 3. So now we have all the three sides are equal. Okay, here is AB is equals to DE. Okay, so this is equals to this. Got it? Yes. So now in triangle ABC and triangle DEF, okay, we know that AB is equals to DE. This is from equation 3rd. Okay, now and we know that BC is equals to EF. This is given. AC is equals to DF. This is also given. So we can write triangle ABC is congruent to triangle DEF. Is congruent to triangle DEF. Okay, by what? By S means side rule. Side congruence rule. Okay, so this is Hans proof. So I hope you understand these things, my dear friends. Okay, so now let's solve the problems. Okay, so now let's solve the problems. Okay, So the question number 1 is triangle ABC and triangle DBC. Here is triangle ABC and triangle DBC are two isosceles triangles on the same base BC. So base is BC, which is same, and vertices A and D are on the same side of BC. Vertices A and D are on the same side of BC. Okay, this line BC. If AD is extended to intersect BC, now we are going to extend AD, okay, to intersect BC at point P. Now we have to show that, okay. Now show that triangle ABD is congruent to triangle ACD. Triangle ABD is congruent to triangle ACD, okay. And triangle ABP is congruent to triangle ACP, means this bigger triangle, okay. And AP bisect angle A as well as angle D. We have to prove also this. And AP is perpendicular bisector of BC. We also have to prove this, okay. So in this question, it is given that the triangle ABC and DBC are what? They are isosceles triangle. They are what? They are isosceles triangle, okay. So now here is in the first part of this question. Now in triangle ABD and triangle ACD, in which triangle you can see ABD means this triangle and ACD means this triangle, okay. Now in this triangle, here is AD is what? AD is common. AD is common. And AB is equals to AC because yes, ABC is a isosceles triangle, so AB is equals to AC, we can say that. And BD is equals to DC because BDC is also the isosceles triangle, so these two sides are also equal, okay. So we can write here as AD is equals to AD, this is common, okay. And AB is equals to AC, okay, because triangle ABC is isosceles triangle. Isosceles triangle, got it. And BD is equals to CD, this is also triangle DBC is isosceles triangle. So I hope you get this point. So we can write as, since triangle ABD is congruent to triangle ACD, okay. I hope you get this point. So we can write here as hence proof. So our first part is complete, okay. Our first part is complete. ABD is equals to is congruent to triangle ACD, okay. So now let's come on to the second part, which is, so second part is, now in triangle ABP and triangle ACP, then triangle ACP. So here is which triangle? A. Now this time we are taking ABP and triangle ACP, okay. In this you can see that AP is common. AP is what? AP is common. And AB is equals to AC. And AB is equals to AC because ABC is an isosceles triangle. And now angle PAB is equals to angle PAC. PAC is equals to angle PAC by CPCT, because triangle ABD is congruent to triangle ACD. Means we can say this angle and this angle are, yes, are equal. Okay, so now here we can write as, yes, AP is equals to AP. This is common. Got it? And angle PAB is equals to angle PAC. This is by CPCT, because since triangle ABD is congruent to triangle ACD. We already proved this. Okay, I hope you get this point. Now here is AB is equals to AC, because triangle ABC is isosceles triangle. Isosceles triangle. Okay, got it? So we can write as, since triangle ABP is congruent to triangle ACP by what? By side angle side rule. By side angle side rule. I hope you understand these things. By side angle side rule. So triangle ABP is congruent to triangle ACP by side angle side rule. So I hope you understand these things, my dear friends. So now let's move on to the third part, which is, now here is, in the third part we have to prove AP bisect angle A as well as angle D. Okay, so now we know that angle PAB is equals to angle PAC. Okay, angle PAB is equals to angle PAC, because this is by the CPCT, as triangle ABD is congruent to triangle ACD. Okay, so we can say that AP means, here is, we can say, if this angle is equals to this angle, so we can say that AP line bisect angle A. Bisect angle A. We can write as AP bisects angle A. So this is, now this is equation number 1. Okay, now in triangle BPD and triangle CPD, means in this triangle BPD and CPD, this triangle. Okay, in this triangle here is, we can say that PD is equals to PD. This is what? This is common. PD is common. PD is common, my dear friend. And BD is equals to DC, because we know that triangle DBC is isosceles triangle. So we can write here as, BD is equals to CD, because triangle DBC is isosceles triangle. Got it, my dear friends? So my dear friends, here is, and also there is a condition, which is what? BP is equals to PC, because we know that triangle ABP and triangle ACP are congruent. So by CPCT we can write BP is equals to PC. Okay, so this condition we are using in triangle, for congruence, for proving the congruence of triangle DBP and DCP. Okay, so we can write here is a third condition, which is BP is equals to PC by CPCT as triangle ABP is congruent to triangle ACP. Is congruent to triangle ACP. Got it? So triangle BPD is congruent to triangle CPD. By what? By triple S rule, because all the corresponding sides are equal. So we can write by SSS rule. By what? By SSS rule. Okay. So we can write here as this angle and this angle are equal. Okay. And this angle and this angle are equal. If these two angles are equal, then we can say that DP is the bisector of angle D. DP is the bisector of angle D. So here is, we can write as angle BDP is equals to angle CDP by CPCT. Okay, so this is the equation second. And our equation first is, AP bisect angle A. So from these two equations we can say that, okay, so now by comparing equation 1 and 2, we can say that it can be said that AP bisects angle A as well as angle D. So I hope you understand these things, my dear friend. So now let's come on to the fourth part, which is, fourth part is, we have to prove that we have to prove AP is the perpendicular bisector of BC. We have to prove AP is the perpendicular bisector of BC. So here is, we know that angle BPD, here is angle BPD means this angle is equals to angle CPD, because we know that triangle BPD means this triangle is congruent to this triangle. Okay, and BP is equals to PC. So we can write as, angle BPD is equals to angle CPD by CPCT as triangle BPD is congruent to triangle CPD. Got it? And BP is equals to CP. Okay. So here is, you can see that these two angles are what? These two angles are linear pair. They are what? Linear pair. So we can write angle BPD plus angle CPD because they are equals to 180 degree. Okay, because BC is a straight line. I hope you understand these things. Okay, and also we know that we can write BPD, angle BPD in place of angle CPD. So this will become twice of angle BPD, which is equals to 180 degree. So this will become angle BPD is equals to 90 degree. BPD is equals to 90 degree. So this is what? This is the second equation. So I hope you understand these things. So angle BPD is 90 degree. and angle CPD is also 90 degree, because these two angles are equal. Okay, so now from this condition and from this condition, we can say that now it can be said that AP is the perpendicular bisector of BC. I hope you get this point, my dear friends. Yes, so now let's move on. Yes, so the next question is, my dear friends, here is AD is an altitude of an isosceles triangle ABC. Okay, in which AB is equals to AC. Okay, now show that AD bisect BC. Now we have to prove AD bisect BC and AD bisect angle A, means this angle. Okay, yeah. So now here is, now it is given that AD is an altitude. AD is what? AD is an altitude and AB is equals to AC. Okay, so we can say that this is 90 degree because AD is an altitude, so it is perpendicular on BC. So AD is perpendicular to BC. Okay, so now in the first part, in triangle ABD and triangle ACD. In triangle ABD and triangle ACD, angle ADB is equals to angle ADC is equals to 90 degree. And AB is equals to AC. Okay, means AB is equals to AC. This is the given part. And AD is equals to AD, which is common. So we can write here as, triangle ABD is congruent to triangle ACD. Now you can see that by which rule? Here is, there is one angle is 90 degree. One and one side is hypotenuse and there is one side. So we can say that these two triangles are congruent by RHS rule. By what? By RHS rule. Okay, so we can say that by the rule of CPCT, BD is equals to CD. BD is equals to CD. BD is equals to CD. Okay, this is what? This is by CPCT. Okay, I hope you get this point. So we can say that, so AD bisect BC. Okay, hence proof. Okay, now in the second part, again by the rule of CPCT, we can write angle BAD. So angle BAD is equals to angle CAD. So this is by CPCT. Okay, so we can say hence AD bisect angle A. Hence proof. So my dear friends, I hope you understand these things. So now, yes, so the next question is, two sides AB and BC are median. two sides AB and BC and median AM of one triangle ABC are respectively equal to the side PQ and QR and median PN of triangle PQR. Okay, means it is saying that two sides AB and BC, okay, and this median AM, okay, two sides AB and BC and median AM are equal to this triangle side PQ and QR and median PN of this triangle. Okay, so now we have to prove. Now in the first part, show that triangle ABM means ABM is congruent to triangle PQN and triangle ABC is congruent to triangle PQR. Okay, so now let's start to solve this question. Here is, now first of all we are writing the given part, given parameters. So given as AB is equals to PQ, okay, BC is equals to QR and AM is equals to PN. I hope you get this point. So here is AM is what? AM is the median. So we can write as BM means this, right? BM is equals to half of BC, and similarly PN is the median, so we can write QN is equals to half of QR, okay, and also here is, we know that BC is equals to QR, so here is, we can write as, we know that here is BC is equals to QR, okay, so half of BC is equals to half of QR. So here is from this condition and from this condition, so we can write BM is equals to QN, okay, so we can write as, from above condition we can write BM is equals to QN. BM is equals to QN. Okay, so in triangle ABM and triangle PQN, AM is equals to PN. Here is AM is equals to PN, which is given, okay, and AB is equals to PQ. So these two conditions are given in the question, okay, and BM is equals to QN. We have already proved this condition. We can write already proved. So we can say that since triangle ABM is congruent to triangle PQN, by SSS congruency rule, by SSS rule. I hope you understand these things. So now here is, now in the second part we have to prove triangle ABC is congruent to triangle PQR. So let's take these two triangles. In triangle ABC and triangle PQR, we know that AB is equals to PQ and BC is equals to QR. This is given in the question. Okay, so now from this condition, from these two triangles, we know that these two triangles are congruent, so we can write angle ABC. Means we can say this angle and this angle are equal by CPCT. Okay, angle ABC is equals to angle PQR by CPCT, as triangle ABM is congruent to triangle PQN. Got it? So we can say that, my dear friends, triangle ABC is congruent to triangle PQR by which rule? By side angle side rule. By side angle side rule. By side angle side rule. So got it, my dear friends? So now here is which rule? Side angle side. Side angle side. Okay. So now, my dear friends, I hope you understand these things. So we can write as proof. Now let's move on to the next question, which is, now triangle ABC is an isosceles triangle. Now we have triangle A, B and C, which is isosceles triangle, with AB is equals to AC, with AB is equals to AC. Now draw AP, which is perpendicular to BC. Now AP is perpendicular to BC, to show that angle B is equals to angle C. Now we have to prove angle B is equals to angle C. I hope, my dear friends, you understand this question. So now now in this question we have AB is equals to AC. Okay, this is given. So in triangle ABP and triangle ACP. Okay, now angle APB is equals to angle APC. They are what? They are 90 degree. According to this question, they are 90 degree. Okay, because AP is altitude. We can write it as also. Okay, and AB is equals to AC. This is given. Okay, and AP is equals to AP. This is what? This is common. This is common side. So we can say that, my dear friends, here is one angle is 90 degree, one hypotenuse and one side. So we can say that these two triangles, triangle ABP is congruent to triangle ACP by RHS rule. By what? By RHS rule. I hope you get this point, my dear friends. So we can write here as, since angle B is equals to angle C, this angle is equals to this angle, by the rule of CPCT. So by the rule of CPCT. Okay, so I hope you understand these things, my dear friends. Okay, so now, my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.